So we have what times what is 2, you add together to get 3. 2 and 1. Group it. Gives you terms of 2x plus 1 and x plus 1, which gives you x-intercepts of negative 1/2 and -1. Same deal now to find my vertical asymptotes. I have to factor the bottom. What times what's positive 4? You have to get -5.
-4, -1.
-4, -1, very good. And my horizontal asymptote. Do we have one here?
Isn't it 4 and 1? Not negative.
Oh, yeah, you're right. You said the terms. I'm like, yes, you guys went x minus 4. Yeah, thank you. My horizontal asymptote is going to be at 2. The reason that it's at 2 is because our degrees are the same. But I was saying you had it right, so I was like, did you get mad at me? Bless you. Just call it the horizontal at 2. So we've got plenty O info.
Plenty of info.
That's the Irish information. O info. Intercepts negative 1/2, negative 1. Vertical asymptotes 4 and 1. Horizontal at 2. Now this is another one of those cases that we wind up with 6 chunks of domain that we need to check where the curve is going. I meant 6, I meant 3 of them, sorry. I was looking at 6 total parts, but if you look at it, there are 3 sections of domain. When we get into pre-calc,
So we moved only 2 points.
How do you know it's only the bottom 3?
what do you mean? I'll tell you one second. What I was saying here, when I'm just pointing to 3, that this domain is occurring, oops. These values of the domain could be occurring down here, or they could be occurring up here. I'm just saying the domain, I'm just looking at my domain values, that's all. I'm just looking at the values of x. That's what I was doing with that. Okay. So we have values to check in this, values to check in here, and values to check on that side. It's just, we have 2 of them here, but it really doesn't help me a whole heck of a lot. So I might just try and see what happens at, oh, I don't know, 0. If I use 0, I'm at 1/4. That doesn't really look like it's going to help us much.
Nice.
Yeah,
Whoa.
That helps.
sure.
I actually have no clue where that.
makes sense.
Well, let's check and see what it's doing at, I don't know, maybe -3. Okay. We use -3. We just (18 minus 9 plus 1 is 10. 9 plus 15 plus 4. Yeah, so 10, 28, so it's 5. So it's 5/14. It's less than a half, right?
Oh, jeez.
Oh my goodness. That was at 9. What does this even do?
Can we go like +1/2?
Yeah. Positive 1/2. What's 1/2 squared? 1/4. So we have 1/2 plus 3/2 plus 1 is 3. 1/2 of 3/2 is 2, plus 1 is 3. Okay.
Is that supposed to be a 3?
Yeah.
Squint.
Oh.
So 1/4 minus 5/2 plus 4. Well, that's 1/4 minus 10/4 plus 16/4.
Add 2.
-9 plus 6 is 7.
That's ugly.
It's more than one.
So it's 3 divided by 7/4, which is 12/7. So it's 1 and change. Oh, it's over 1.5. So which?
Here we go.
So at 1/2 is 1 and 5/7. So that's weird.
It like goes through
Does it?
it. Yeah.
Oh, you know why? I bet you there's a hole here. I bet you they put a hole. There's a hole when you. Does the curve do this?
Yeah.
How is there a hole?
Okay.
That's not a thing.
Well, the lines die.
Okay. Here's why. What if we go?
I got that.
If we go back,
That's funnier than his joke. Yeah.
what happens sometimes?
Rebecca was
2x squared. Was it 3x?
Yep.
Yeah.
Plus 1?
Yep.
Thank you. X squared
Minus 5x.
plus 4. See if this shows up. Okay. What happens here is you get this weirdness that can occur over asymptotes. And it happens with upper degree polynomials. And you can get jumps. It's decreasing like we saw, and then it goes through that horizontal asymptote. That horizontal asymptote with our coefficient over coefficient, as it comes through here, as it's increasing in our table, let's see if it shows it. We have our regular asymptotes at 1 and 4, like we already had found. Okay? And you'll notice it jumps between, where was it? At -1/4. Then we had the asymptote at 1, but then it was down below at 2. What happens here as it's getting closer and closer to here, it is increasing, but there is some value that would technically be a hold. All right? We study that piece in pre-calc. It's not that big of a deal here. And then obviously we would find our 2 points that would give us the curve here, and then our other ones that would just tail themselves out. Sir,
So that won't be on the class.
what'll happen with the quiz stuff for tomorrow, anything that I give you as far as graphs and things like that, it will be values that you will be able to figure. It'll be values that I tried my best to make sure they weren't those, like that horrible fraction one. So if you pick numbers that seem in your mind that should make sense, you should be okay. Whereas if you pick like, I'm gonna pick 10, you might get a really nasty number. But if you pick the numbers closer to the asymptotes, it should work. And I can try my best to do that for you guys, so you don't sweat the minutia of it. Does that make sense on there? No, you don't know what those are yet. We'll worry about that later, okay? But the idea here was, could we still figure out all of our asymptotes? Could we figure out our domain and ranges? Could we do all of that without too much of a pain? Yes. What else want to look at?
36.
Hey, this
So, we need to factor the top. What times what's 20 add together to get negative 9?
-4 and -5.
Yeah. So we have x-intercepts at 4 and 5. We have vertical asymptote at,
0.
very good.
And then no horizontal.
And then horizontal asymptote,
Oh, you have to find that.
none. But we're going to find our slant then, because it's 1 degree higher.
Then
So when we do that, we take our 2x into x squared minus 9x plus 20. So it's 1/2, oops, 1/2 x. Let me put in a plus 0 here, just so I have a little placeholder. Subtract out, I get negative 9x, drop it down to 20. Now I have to multiply it by negative 9 over 2. And I really don't care about my remainder. I just have my linear. And it winds up at 1/2 x minus 9/2. 9/2 is what? 4.5. Okay. So that's not a bad one to find on a graph. Same thing when we did earlier. I had that 4/3. It's just a smidge off the line. Would be okay to kind of fudge your way through it, if you will.
Are these like the sort of problems that are going to be on the quiz?
Yeah, I mean, I can't think of,
Like, there's not going to be anyone that tricks us.
I can't,
So what,
Will you get to that?
so what do we do with the slant asymptote? Just graph that, right?
No.
When the top degree is always bigger than 1, should we always find the slant asymptote first?
If it's, let's say it's a cube and an x, then you're not going to have a slant.
Yeah.
If it's 1 degree separated,
Yeah.
then yeah.
So should we find that first?
Yeah,
Okay.
it's helpful.
Are we ever going to have an x?
You could. It works the same way.
So
The
then-
question was if you had x cubed and x squared. If you have x cubed up top, x squared on bottom, doesn't it work the exact same way?
Yeah.
It works the same way because you're still, when you divide it out, you're going to get a linear function.
So since it's 1 still, you still find the slant asymptote?
Yeah, it works the same. Works the exact same way. So we plotted our intercepts, 4 and 5. We had our vertical asymptote at, what was it, 0? We had a horizontal asymptote at 1/2 x minus 9/2. So we start at negative 4.5. Up 1 over 2. Down 1 over 2. And then we put in our line. And since you probably noticed where those 2 dots are in that portion of the graph, the other 2 should be mirrored down below that somewhere. So you just take a guess about how far out you should go. Maybe also try -4, -5, or -4, -3. Okay? One might work better than another, you never know. So if you use -3, if I use -3, I get, what would that be, 9 plus 27 plus 20 all over -6. So that's 47 and 9 is 46. 56. So let's see, that goes what? 8 would be 9, so it's -9 and change, 9 and a third. Why would you use 0? Can't use 0. So I say -3, -9 and something. to use -1? Okay, use -1. I need -1. -1 squared is 1 plus 9 plus 20 is 30. Divided that by -2. I have -15.
What's that?
Which means it's down here. So it's still probably hugging the curve and coming down and doing that. Just like this one's probably doing this. Okay. So you've got your ordered pairs to go through.
Are we gonna have a difference of cubes?
If we had a difference of cubes, remember if you had to find a 0, it was just that first part. So whenever you have a difference of cubes, no matter what it is, if it's x cubed minus 8, if that was in your numerator, normally you would have to go through and factor all that, but if you just have to find your x-intercept, wouldn't that just be the same as setting it equal to 0? And you just take the cube root of it and get 2. That's all it is.
X cubed plus 8.
Same deal. If it's x cubed plus 8, you get -2.
Oh.
Because cube roots, you can have negatives.
Yeah.
It's not a plus minus because anytime you have an odd number of negatives multiplied together, you will always get a negative value.
So you don't have to worry about the other part of it?
No. When you're coming to factoring and trying to find a 0, because that secondary portion, when you do the difference of cubes like that, it's going to be an imaginary solution. Okay. Or it's going to be a non-rational. It's not going to be pretty. So I don't think I've ever seen one that works. Does that take some of the angst? No, you whine too much. You go to. That's what happens when on vacation.
How do you know when some of them are on straight lines, like number 28 and how
What do you mean? Well, there's no vertical asymptote. There's no vertical asymptote because there are horizontal asymptotes. So as you start to get your point, you work yourself through. So you're saying 28. That's a good question. When you start to think about what the curves themselves are going to look like, when you don't wind up with your vertical asymptotes, like in this example here, we have imaginary solution denominators, so you don't have to worry about it. But we have two x-intercepts. We have x-intercepts at plus minus 2. I have a horizontal asymptote at, what is the y equals 1, because it's coefficients. Since there's no vertical asymptote, this is a good candidate for looking at your y-intercept. You have your 2 points here and here. I can plot my y-intercept without too much of a hassle. It's -4/3. And I have this asymptote here. So what's happening is that it's following the asymptote, curves down, and comes back up. Because there's no domain restriction to keep it from doing that.
Wait.
That's basically what it works out to be.
Wait, so if you don't
There's no
have,
vertical asymptote point.
if you don't have a vertical one, how do you find y, or the y intercept again?
Set it equal to 0. Set the x equal to 0.
So you do.
Yeah.
So that's what it will look like.
So it's a
You got so
-4/3.
excited.
Yeah, if you pop it in like that. I mean, you can still pick points out here, and you're going to get the same idea of curve.
Okay.
This is basically what's going to look like right now.
So if we have to pick
Hold on, give
points,
me a couple seconds.
Maybe.
I need to look at this real quick.
I mean, it just depends on the problem. It really does.
so if we did pick points.
Oh, did I put it at 2? I meant to put it at 1. I'm sorry. That should be at 1. Well, I realized I put my horizontal asymptote at 2 when I graphed it. It should be here at 1. My graph is too tall.
Wait, so if we did pick points on that one, we just pick random.
Yeah. Yep.
Like a little curve.
Yep. My guess here is that you guys would probably pick 0, 1, and 2
Yeah, that's what I would.
because it's very easy to work with.
I think
And it can't be on the dash line.
Correct. It won't be on the because you're not going to pick a horizontal value. You're always going to pick a value of x that generates the horizontal value. Okay. You always pick an x to generate a y. Okay.
Wait, what is the line?
Still what I wanted to look at.
I have rejections at 1. But then, or, yeah, 1. But it can't be on 1.
If I look at 32, 32 is another example of top equaling the bottom. I don't think we had to do it, but we might as well look at it. 32 is another example. Yeah, it's cube over cube. 32 is another example of top equaling the bottom. You're welcome. And what happens here, you still have to figure out what your intercepts and stuff are going to be. So in order to find your x-intercept on something like this, it's 3x cubed plus 1 equals 0. Okay. Subtract 1, divide by 3. And then you take the cube root.
Would we have our calculator for this part? Or no?
No.
So we'd have to do that.
Yeah, and here's the thing. Yes, you have to rationalize this, but you don't know how to rationalize a non-squared value yet. So if this was the case, you could leave it like that as your x-intercept. Now, in any calculator, whether it's a dumb calculator or your fancy calculator, you could take the cube root of a fraction and putting in a little negative symbol there and get some decimal equivalent. If I do that, the cube root of 1/3 is probably 1.04-ish. I don't know, I'm making numbers up. Your best numbers, what are you?
26.
Let me finish this one real quick.
There's 14 numbers and 18.
Oh, it's all non-calculator.
It is?
Yeah.
What if I like mess up like the simple math? Like for you, 4 times 5 is.
There you go. So there's your decimal. Negative half-ish. Sir?
How do you do the cube root?
In what?
Like how do you?
Math? 4.
Math 4. Got it.
Or in some other calculators, it might look like, see option 5 here, you see the x roots? A lot of the old calculators, the old non-smart ones, would be x root. You type in 3x root, whatever, and it'll do the cube root for you. Let me finish this one out then. So you know your x-intercept is roughly negative 0.6, what was it, 6.6 or 6.9?
0.69.
So it's roughly around there. Denominator, this is where you've got to worry about your vertical asymptotes. What are the zeros of the vertical asymptote? Same idea, you set this equal to 0, so you wind up with x cubed equals 8. Add 32, divide by 4, so your vertical asymptote is at x equals 2. I don't have to worry about the factored part of it, the quadratic, because I know that's not going to give me a real solution, so I don't worry about it. So now I have my x-intercept, my vertical asymptote, and I also know that my horizontal asymptote would be where?
That, 3/4.
Why is it 3/4? Because top equals bottom. Coefficients are the same. So I can go through everything now and say, all right, my domain is all real numbers except 2. X equals 2. My range is all real numbers except y equals 3/4. I have no slant asymptote because my degrees were the same. And then I have an x-intercept at the cube root of negative 1/3. I can list all that. I don't even need a graph if I don't need to. I don't know. Depends on what it asks you. Because we've done problems where you had to graph it. We've done problems where you haven't had to graph it. You just had to list stuff out. No, you were saying 26? Yes. Second. All real except for my horizontal asymptote at 3/4. When you long divide, did you not put a placeholder in?
No, I did.
Oh, okay, never mind. I was just guessing that's usually what people will forget. So we have x-intercept. 2x squared minus 3 is 0. Set it equal to 0. Add 3 divided by 2. We get x squared is 3 halves. So x is going to equal plus or minus the square root of 3 over 2. Now, plus minus 3 over 2, you should be able to rationalize. Remember, when you're rationalizing these square roots.
Wait, is that the x-intercept for everything?
Yeah.
Also, there's the square root of 3 over 2, like I know what it is.
Oh, wait,
I didn't
what's
do
it?
that.
When you do that, you have to multiply the top and bottom by the square root of 2, so you get plus minus root 6 over 2.
Oh, I copied it
And that's the x.
That's your x-intercepts. Yeah, plus minus
Y
root
equals
6
4
over
x
2.
plus
I just put none.
Yeah, you're
squared
When
minus
do you
4.
rationalize?
I did too.
Anytime you have a radical in the denominator is bad. Just like I in the denominator. Same rules apply as it was in geometry. Okay?
Could you just say there was not an x-intercept and just do your own points? Like, I don't know how to explain it, but like, never mind, it's just,
You have x-intercepts, so that's the thing.
I just didn't want to do this.
Okay, you set it equal to 0. Vertical asymptote. No, because you can rationalize that. I expect you to rationalize square roots. I don't expect you to rationalize cube roots because you don't know how yet. Okay. We will have a slant at this point. So our slant, we take 2x squared plus a 0x minus a 3, x plus 2, multiply it by 2x. Subtract out, and multiply it by negative 4. And then we get, well, it doesn't really matter if you don't care about our remainder. So we have a slant asymptote at y equals 2x minus 4. We have x-intercepts at plus minus root 6 over 2, and vertical asymptotes at negative 2. When you go to plot that then, bless you, when you go to plot that then, vertical at negative 2. Negative 4 up 2 over 1. Put that in. And x-intercepts were what? Plus minus root 6 over 2. Even if you have a dumb calculator, you could get a decimal equivalent of the square root of 6 divided by 2, and it's 1.2 and change. And the other one would be at negative 1.2 and change, right? Hey, what's between those 2 points?
0.
A 0, right? So if I use 0 real quick, what's your y-intercept?
It's like 2 and negative 2 and
Negative 3 halves, so it's negative 1.5. So hug the asymptote, through some points, hug the asymptote. Which means that your other ones would be somewhere in this range in here. You might not get the best point values because it's a very narrow band. You might have to use, what is this, negative 3 and then something else. Just when we do the stuff on quiz, I worked really hard to get values, if you have a slant, that they place themselves within the range that you can define.
Thanks.
Okay. Because I know you guys can find the slant in the equation. That's not a really difficult process to go through. I don't want you guys to get garbled up in the difficulty of the actual point values. So I tried my best to make sure that those slopes weren't so steep so things get to balance themselves out. There's little tricks and things that I know to graph to make an end result different just by playing around with values. Numbers are weird. Yeah. Sorry, I was figuring I need a little bit more space. Trying to think what else there is. One of the things that I was looking at as far as the stuff we've done all these weird ones. 3.2, that was the other stuff with the, it was a over x minus h plus k, where you had the horizontal asymptotes, vertical asymptotes, just pick points.
If the numerator is like, say negative like 24,
Uh-huh.
and there's nothing else, would it be no vertical asymptote, or would it be,
The numerator?
yeah,
The numerator is only.
If the numerator then just has no x-intercept.
yeah.
Yeah, you're not vertical asymptote. Vertical asymptote's always the
yeah,
zero
yeah,
that denominator.
x-intercept.
Yeah, then there's just no x-intercept.
Yeah.
One of the other things that comes with the idea of the stuff we were doing on Monday, I think? Yeah, Monday. When you had these. Wow, that's awful. When you had those. Even if you went through your checklist of doing things like this, it still works.
Works the same.
Very similar, except for that K value. That K value is your vertical. Remember your vertical asymptote? X equal H, your horizontal asymptote. Your X equal H. You set that denominator equal to 0. Oh, sorry, I had that backward. The K value was your horizontal asymptote because it was going up and down. X equals H was your vertical because you can't divide by 0. Then that last one was the idea where you had the top and the bottom were the same coefficients. It was just two linears. And it's the same thing if they're both squares or cubes. So it kind of falls into the same place here. What else there is? Go back again. Oh yeah, joint and we'll just put that on the test. Let's just give me graphic stuff tomorrow. How's that?
9.2 and 9.3.
So there's no joints.
Wait, the only
No, they're illegal.
That was actually a good one, right?
That we got
Actually. Wait, so it's just 9.2 and 9.3?
Let's go 9293 on this one, okay? We'll put that back in the other on the second part because it's a little bit more of the algebra stuff. To be honest with you guys, 9293 is all the graphing. Everything else is algebra. You should be back to normalcy and somewhat happiness major when we get to that. All right. Questions that I would probably look at in 9.4 at the very end of 9.4. I think it's at the end of 9.4. It is not at the end of 9.4. It might be at the end of 9.3. Yeah. At the very end of 9. No, it's not at 9. Oh, there it is. At the very end of 9.3, there's 6 extra problems with graphing. Those wouldn't be a bad one to double check because you've done basically all of them. All right. Pick numbers. What's that? Oh, I need to get some more out. I had to ration them per class period because my geometry class everybody wanted one I had to say no to them. So I have to save them for other classes. Yeah, I would take a look at one of those 7 through 12 there. They're very straightforward. Actually, what you were saying, how do you graph that one? Just pick numbers. If it's 10 over x, what can x be?
I missed one against Rochelle.
5.
Then you get 2. What can x be?
What can X be?
Can't. 0.
0.
You have a vertical asymptote at 0. Do you have a horizontal asymptote? The reason is because your top degree, well, look at this, your top degree is less than the bottom degree, so you have one at 0. So, little things like that. All right?
Wait, okay, what problems can we practical?
So I was just saying. I do those.
What numbers do you accept?
This is great. This is the only ones you haven't done.
Here's the homework from Monday.
Thanks, Melms. You're the best.
Yeah.